Welcome to this special edition of Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle, and today I'm talking with Bryan Goldstein, Vice President of the Aerospace and Defense Group at Analog Devices. Welcome back to the show, Bryan.
Thanks, Pat. How are you?
Yeah, I'm doing well. You're always one of the big hits for our Frequency Matters interviews, so glad to have you back.
Thank you.
So we're seeing a significant increase in interest and investments in the space industry. What are the factors you think are driving this?
Yeah, Pat, we're embarking on an exciting time for the space industry. There's an unprecedented level of investment coming from a broad array of sources, including governments and venture capital funds, private corporations, and even ultra net worth individuals. Several trends are aligning right now, making this proliferation of the space economy more pragmatic and realistic, and is ushering in all this new investment. First, these factors, they include an ever-increasing demand for data bandwidth, which we talk a lot about. This is driving the need for the latest and greatest high-performance semiconductors. We're also seeing dramatic reduction in launch costs from approximately $200 million each to less than $60 million, which is making it economically feasible to send a much larger number of missions to space each year. And these costs are only expected to keep declining. And then the newer satellites are much smaller and lower weight than in the past, which significantly improves launch cost per vehicle by allowing the transport of many satellites per launch. And lastly, lower cost satellites with much shorter duration missions allow for relaxed mission reliability requirements and now enables commercial-like manufacturing scale. We're talking about mission lifespans of 5 to 7 years as opposed to historically 10 to 20 years. The satellite design and build curve has been dramatically reduced, with the development timeline now closer to 3 to 6 months as opposed to 3 to 6 years. This quick turnaround time requires a new mindset where there's little time for custom semiconductor development, with customers instead willing to leverage multi-market commercial technologies to get products into space much more quickly and efficiently. And this puts companies with broad portfolios like Analog Devices in a very unique position.
So how has the emergence of these new opportunities impacted ADI's strategy in the space market? I imagine, you're using a lot more of these standard products and upscreening them.
Yeah. So first of all, the combination of Analog Devices and Hittite microwave and linear technologies have been serving the space industry for over 50 years. And we continue to support our classic Class S and Class K customers and space portfolio for deep space and applications that require the highest levels of reliability and performance. And these applications often require some level of customization in packaging and testing or screening. And the lead times of these products can be anywhere from 3/4 of a year to multiple years, depending on the level of new product development. But the newer missions in LEO and MEO orbits are requiring much quicker lead times and lower price points. But in exchange for this, the customers are accepting products with less strict screening and packaging requirements. In LEO and MEO orbit, the radiation requirements are significantly lower than GEO. And because the lifetime survivability of these satellites are significantly shorter than GEO, the reliability and screening requirements can be greatly reduced. In reaction to these new requirements, ADI has introduced a new family of commercial space products. And this allows us to better align with the requirements of these newer missions. Our new commercial space portfolio optimizes the packaging and the screening requirements for the mission in order to minimize lead time and cost. More specifically, these products are in our standard plastic packaging, which allows us to follow our standard commercial assembly processes. On top of that, we then guarantee radiation performance, and we have two different reliability screening paths, depending on the application and the reliability requirements. This new family of products, it allows our customers to get to orbit much quicker. It minimizes the size, weight, and power and the cost. And it allows them to use our latest and greatest and most advanced silicon nodes. For example, we're releasing the 809213 and the 809176 ADC and DAC pair, which is on a 28 nanometer node. The 9213 is a 12-bit, 10 gigasample per second ADC, and the 809176 is a 16-bit, 12 gigasample per second RF DAC. And these new products, they're greatly advancing the rates that we can sample at, and is really changing the radio and RF sensor architectures, making them much more simple.
So how have customers reacted, and what are they expecting in this area?
That's interesting, and it's also, the reaction has been somewhat as you'd expect. We're finding that the commercial and the newer players in this market have been extremely aggressive, and they've been very quick to embrace this new commercial trend. They're willing to be a bit more risky. They understand that the cost versus reliability trade-off needs to be made to make high volume constellations economically feasible. On the other hand, the traditional space customers have tended to be much more conservative and are slower to take the risk into the new class of products. However, there is a growing realization that for many applications, full space qualification is not required and may not be even affordable. And as actual real life flight data is starting to be accumulated, I expect that we'll see this shift accelerate. And also, Analog is working with many of these customers to help define their optimum solution. Some absolutely need Class S and Class K, and some just don't need that for their mission. And so we're proving that quality can be had without adding unnecessary costs. And we're backing this up with real flight history and data, which is helping prove out the viability of this market shift.
So what product families have shown the most relevance for these emerging applications?
So, as you know, we've got a very broad portfolio, and we work with our customers engineering complete signal chain solutions using the full breadth of our products. And on a satellite, ADI has solutions that are in the telemetry and control area, the communications payload, the onboard processing, as well as the electrical power systems. And so areas that we're really excited about in our portfolio include our RF solutions, including our GaAs and GaN amplifiers, our new family of silicon beamformer ICs, our RF control products. And we're also excited, as I mentioned before, on the family of our 28 nanometer silicon based digitization products, and as well as our growing portfolio of signal conditioning and power management products. And then just lastly, in terms of capabilities, we're starting to provide an increased amount of heterogeneous signal chain integration in the forms of SIPs, system and package, which is allowing our customers to minimize size, weight, and power, which is required as these satellite systems are getting smaller.
How do you see the space market evolving from here, given where it is now?
So first, in communications, we see the continued desire to provide broadband internet to rural locations, which is going to continue driving the launch of these mega constellations, numbering in the thousands by the likes of SpaceX, Telesat, and Amazon. We're also seeing Earth observation desires continuing, driving some of the smaller players to deploy new constellations. We see launch costs continuing to reduce, and a desire to see them reduce further. We're seeing more customer adoption of less stringent radiation reliability requirements, which is again driving our commercial space products into LEO and even GEO constellations. We see a continued evolution of the capabilities and quantities of LEO satellites as real life data is being acquired. We expect broader worldwide deployment beyond the typical countries that you've historically expected. We're seeing smaller countries start to launch their own satellites. And we're seeing a rapid expansion of defense capabilities with improved communications, GPS, guidance, and remote sensing driving their needs.
How about new technologies? Are you seeing any game-changing technologies that are on the horizon coming?
Yeah, absolutely. So for ADI, we think we've got a handful that we're working on right now. So first, we've just released the extremely low power consumption Ka-band beamformer ICs, the ADAR 3000 and 3001, which are used for communications phased array antenna on satellite. And we've recently announced that these will be an integral part of the Telesat Lightspeed constellation. We're also working on other frequency bands other than Ka-band that are meant to be space-based. We also have versions that are airborne and ground-based. We're releasing a family of high-frequency ADCs and DACs, which are dramatically simplifying RF signal change in space. Like I said, the 809213 and the 809176 will be our first two product releases. And lastly, we're providing integrated solutions, like I mentioned, SIPs, the 80M FM 2000 and 2001 are multi-band up and down converter SIPs, which are dramatically reducing the size of these historically up and down converter modules, are now surface mount SIPs, very broad band to cover multiple frequency bands. And so overall, Pat, there's a lot of excitement about where the market's heading. And frankly, space is just a really cool topic that everyone likes to talk to us about.
Yeah, it is an exciting time. We see in space tourism, all these large constellations going up. So there's a lot going on in the market. Well, thank you, Bryan, for talking with me today about the space market and how Analog Devices is meeting those challenges. You guys have a really broad portfolio and really do the whole signal chain. So it's very interesting to check out those products. We always appreciate your perspectives and hope that you'll come back again soon. And to our viewers, you can watch more interviews and episodes at videos.microwavejournal.com. Thanks for watching today.